Hello, DjangoCon Australia. It's a pleasure to join you from the other side of the world in London, England, but due to the time zone shift, I have pre-recorded this talk. I'm Adam Johnson. I'm a member of the Django technical board, and I'm here today to talk about what happens when we run manage.py. This is a topic I'm very interested in because I love testing. I've written a book about it, and if we dissect the test process, we can customize it. So you might be treating the test runner as a bit of a black box. You write your tests, you write these classes and these functions inside them, and you know what's going on inside your tests. Perhaps you understand a little bit about the help that's provided to you inside a test case, but the test runner itself is a command you invoke and it outputs the results on the screen and does a bit of help for you. But if you've never looked inside the code, you might not even know anything about how it's working. So this talk is going to open that up and take a look inside. Why would you be interested in learning this? Well, I can draw an analogy with middleware. So before you knew middleware, then you wouldn't have known how to change cookies, set headers, log every request going through your system, or do any number of fun things. So once you know the concept of middleware, you can unlock these use cases. Similarly, when you know how the test runner is working, you can unlock many different use cases, perhaps some that you've thought of but never been able to implement, like changing the way tests are loaded in your system, restricting them or pulling them from different directories, and changing your test settings without needing a separate settings file, or putting in a blanket block on all outgoing HTTP requests so your test suite doesn't accidentally make unmocked calls to third-party services. In this talk, we're going to cover a particularly vital customization to the test runner, and that is changing those boring dots, E's, and F's into fantastic color-filled emojis. So by the end of this talk, we're going to have the test runner outputting all these explosive explosions, crosses, green check marks, and other symbols. Let's get started. We're going to first dissect a test run from the outside and look at its logs. And for the purposes of keeping it all about what's happening in the test runner rather than what's happening in the tests, I've set up a simple project that contains only this one test case, with this one test inside that does nothing. If we run this, we get some familiar looking log output. And on the first line, I run the command manage pytest, and then we have lines at the start and end, creating and destroying the test database, and a dot for the symbol, a dot to represent the test running. We can investigate a little bit further than what we're seeing here by using verbose mode, which we do by passing -v3 on the command line. So when we do that, we get a little bit more output and we can investigate it in more detail. So we've got that first line, creating test database, and your eye might be drawn to the opposite of it, destroying the test database at the end. With the verbose mode on, we're now seeing that there's a path to the database, file memory DB, and then a bit more that I've cropped off to the right. This project is using SQLite, not something that everyone uses in deployment and therefore probably shouldn't use in tests. But if you do use SQLite, then Django will automatically swap to a memory-based database for test running. So that's about 10 times faster. If you're using a traditional server-based database like MySQL or Postgres, then it won't support a memory mode out of the box, but you can put it on a memory-based file store to gain the same speed difference. Once Django creates this test database for us, it then migrates it. And so we have the next series of output from operations to perform all the way down to no migrations to apply. This is all the output coming from the migrate management command. It's the same as we'd see as if we ran it on an empty database normally. This app that I'm testing with, it has no models, no migrations, and it's the only app. So there's not much going on here in the output. If we had many migrations, we'd see one line of output per migration. Django will migrate all your test databases in projects using more than one database. Each of them will be created at the start, destroyed at the end, and then migrate will apply to all of them. So again, this is maybe a simpler project using only a single database. Following that output, we have the system check identified no issues line. This is Django's system check framework, which you may not have explicitly worked with, but it's always there providing a bit of protection against misconfiguration. It performs a number of pre-flight checks in order to investigate how you've configured Django, things that couldn't be done by a linter and need to be done at runtime. And if you are writing tests that do this kind of thing, it might be worth investigating writing your own system checks to do the same thing, because they run first before tests ever get invoked, so they can provide an extra level of protection before you go into expensive tests. The next section in the output is the actual running of the tests. In verbose mode, we get one line per test with the whole test path spelled out, and then its status, which is here OK, meaning the test passed. Otherwise, it could be error or failure or one of the other modes. Following this, we have the summary of the test run with a ruler and then the number of tests that run in the time period. If we had any errors or failures, they'd be reported here in brackets. There's a final status report saying OK or fail. And then we have that line about destroying the test database. So having read this log output, we already have some idea of the steps the test runner must take. So we can write these down in a list. So step 1 would be to create the test databases. Step 2 would be to migrate them. Step 3, run the checks, then run the tests themselves, report on the test count and the success or failure, and destroy the test databases. So we now have a rough idea of what we're going to be looking for in the code, so we can go and investigate it in more detail. Before we dive into the code, it's worth noting the relationship between Django and unit test. Django's test framework is not a thing in itself. It's based upon unit test, which is built into the Python standard library. Unit test itself was based upon ideas from a library called JUnit, a Java unit testing library. And that's why it has all this class-based arrangement, these functions called assert equals in a non-Pythonic camel case format, and some other quirks. And part of its design that we're going to be looking into was copied from JUnit. The first place to start is the test management command. Whenever you run any management command in Django, it will look up a corresponding module in a management commands directory and run that. For built-in management commands, they live in Django's core management commands directory, and that's where we find test. Looking inside that management command, it's not particularly interesting. It's rather short. It's less than 100 lines, and I've simplified it and put up just the key lines here in the handle method. And inside of that, there's references to get this test runner class on the first line, and then instantiate it, and then call its run tests method with the set of test labels that have been passed in on the command line. This returns a number of failures that are used to determine only the output code here, the status command on the terminal if any of the tests fail. Given how short this is, it seems worth it to track down this test runner class and find out what that's doing. And this leads us to a class called Discover Runner. Discover Runner is the name of this test runner class that's built into Django. It's not called test runner for some reason. I think it was due to a change in test discovery in Django 1.6 or something like that. And here's how the class starts, with a number of class level attributes that point to other classes. And we can see 3 of these are part of unit test, and there's this parallel test suite class. This lives inside Django's test framework, and it's kind of an extension to that test suite class that is referenced above. So we've got one class that references several other classes. Why don't we dive into the run tests method that we saw to see how they get used? So I've simplified this method again, just to show the main details of it, and it just calls to simplify the main details, it calls all these steps in order, and some of these we can already see correspond to the steps in our checklist that we wrote earlier. So we've got this get databases, set databases pair of lines. The get databases line is something that we maybe didn't consider, but Django will only set up test databases if tests require them, and only set up those databases that are required. So this checks which databases are needed and then only sets those up. The setup databases function is actually creating the database and calling migrate. The system checks are run through this run checks method. The tests themselves are run through run suite, which we'll look into a bit later. And there's also the teardown databases corresponding to the log line that we saw earlier. The final return value from this method is coming through suite result, and that's the number of failures variable that is used up in the test management command to determine the exit. Two other methods that perhaps we hadn't considered from the logs were setup test environment and teardown test environment. These aren't very big. They're changing a few settings to be appropriate for tests and controlling a few features such as the testing mail outbox, which you may have used to detect whether a function sends an email. There's two methods here which I'd like to dive into. That's the build suite and run suite methods. These are where Django hands off work to unit test. So first looking at build suite. Again, this is simplified for readability, but the core skeleton is there. The first line is calling the test suite attribute. This is one of those attributes pointing off to a class inside unit test. So this line basically instantiates that class. Once we have a set of test labels, which if they weren't passed in by the user, Django defaults to finding all tests in the current directory. These are looped over, and then the test loader class that we also saw is used. This thing doesn't get instantiated. Instead, its class level method load tests from name is called. And that method returns a kind of list of tests, and then the suite object acts as a container for all the tests that have been found, and the add test method is called over and over to add more tests into the suite until we've collected everything that was referred to by label. That parallel test suite class we saw earlier is used here and acts as a wrapper to the unit test suite class. It has similar behavior, but it's concerned with handling multiple processes to run the tests rather than a single process. So that's build suite. Let's look at the other method, run suite. And this is kind of where the magic happens. Django has set everything up in the test environment, found all the tests, and it hands off to unit test to actually run those tests. There are a couple of sub-methods it's calling. The first is get test runner quargs, and that is basically building up a dictionary of keyword arguments to pass through to the test runner class. This is needed because it customizes some stuff about that unit test runner. And here's where we construct the test runner from the class level attribute using those keyword arguments. It's worth pointing out here there are really two distinct concepts of a test runner inside of Django's test framework. There's its own test runner, that's this discover runner class we're looking through at the moment, and then there's the unit test runner class. Perhaps Django's class would have been better named test coordinator or something similar to indicate its greater responsibilities than the unit test runner, but we're probably not going to change that now. So we've now seen how discover runner uses all those classes it refers to hand off work to unit test. It's worth diving into this test runner class to see what that's doing. So in unit test, this is actually called text test runner. And the class starts like this, again, a bit simplified. It itself has a class level attribute result class referring to another class. So we've got the same pattern we saw in Discover Runner with classes referring to other classes. It's slightly different to the way Discover Runner works because you can pass in an alternative result class to its constructor. This is actually something Django does, as we'll see in a bit. If we were to map out everything we've explored, it would look a bit like this. We have the test command, which hands off to Discover Runner. Discover Runner refers to 3 different classes within unit test. That's the test suite, test loader, text test runner. And the text test runner itself has a reference to another unit test class. The default is text test result. For our emoji customization, you might have already guessed we'd want to change something to do with the test runner or the test result, as this is when the output is made. And indeed, it's inside the text test result class that the actual output is made. These classes use the name text to represent that they output human readable text to the screen. There are alternatives like using an XML file output that your CI software can use to display the list of run tests. So how are we going to customize the test process? Well, we can only really affect the things on Django's side because there aren't settings that affect unit test, and that gives us 2 options. The first is to override that test management command. As we saw though, it's quite short and it's not worth swapping out because most of the work is in the test runner. And so for this, Django provides the test runner setting, which you can use to point to an alternative test runner class. And it's a Django test runner or test coordinator, as I'd perhaps like to call it. So let's try that. Let's make the simplest possible customization and create a very fast test runner that skips all of that work that we've been looking at and simply outputs an A+ result. This will make our tests execute instantly and might impress some people. Our first step would be to subclass Discover Runner in a module. Here I've used example/test.py, and within that class we're going to make one straightforward replacement of the run tests method. We'll replace it with this 4-line very fast function. It takes any number of arguments and keyword arguments. They're not used. It prints out a message that all the tests have passed and you score an A+, and then it returns 0 failures so that the test management command exits with a success code. Once we've set that up, we can swap it in using that test runner setting, pointing to the class using the dotted string format. Then when we run the tests, we get this A+ message, everything looks great, and the tests are now as fast as they possibly could be. So that's a trivial example. Let's move on to the moment you've all been waiting for, how to get emoji on your screen. We're going to follow the same plan again to override Discover Runner, but then we also have to override that result class we saw on the unit test side of the diagram with our own subclass. So one method we didn't peek inside before on the Discover Runner class is this getTestRunnerQuargs method. And this is the full implementation. It's passing through a few options from the command line, but also it's passing this getResult class here as a keyword argument to constructing the text test runner from inside unit test. So it looks like Django is already replacing this. And if we dive into the getResult class method, we'll see how. This is the full method again. Essentially, there are 2 options to Django's test runner that change the way it performs output. You've got the debug SQL option that will output every SQL query that gets run. And you've got the PDB option that will launch the Python debugger, or PDB, whenever a test fails. This method implicitly returns none at the end because it doesn't have a final return statement. And that none is replaced with the default in the test runner class from unit test. So our idea to customize the output always is to detect that none and then replace it with our own subclass. So here's what our custom test runner class could look like. We call the super getResult class in our own getResult class method. And if that happens to return none, we actually return our emoji test result class. So what should go inside our emoji test result class? Well, for this, we would need to do a bit more digging to find out what's inside the default text test result class, but I can show you the start. So we'd want to inherit from that, just as we inherit from Discover Runner, and then swap out just part of the implementation. This class implements both the default and verbose output, that is the single dot or the whole line of output per test. Inside its init, it sets a variable called dots to true if it's meant to use the dot style. And here we can take that variable and assign it to a different instance variable called emojis, so that we know if we're meant to display emojis. And then in a hook method like this add success, we can output the success emoji. There's one hook method for every possible test result. So you've got success, failure, unexpected success, unexpected failure, etc. And that's why I've not shown them on this slide, but they're all in the example inside the repo for this talk that I'll post the link for later. So having set the test runner setting to point to our custom Discover Runner subclass, we can run the tests and get the emoji output. That's a lot more colorful. So having taken a tour of the test runner architecture, we can now think about some of the problems with customizing it. This method of classes referring to other classes is simple and not too hard to debug, but it becomes rather limited very quickly. Imagine if we tried to implement emoji output on top of the debug SQL and PDB output options provided by Django. Those are provided in separate classes to our emoji test result class, so we'd need to build other subclasses that use multiple inheritance to put them all together. This is like a general problem, and any of those pieces from unit test or Django's Discover Runner class itself that we swapped out, if we wanted to pull in two different sets of customizations, that would need to be done through multiple inheritance. So this is a style of programming based on inheritance rather than composition. Because this design is not composable, there aren't really any plugins out there. Installing other people's plugins means a lot of faff with these classes, and there's no guarantee that they're compatible. I know of only two extensions that are used with Django's test framework. One is called Unit Test XML Reporting, and this is used on Django's own CI system. This changes the output to record an XML file alongside the normal text-based output. So the CI system, Jenkins, can make a report upon the status of the tests. Another one is Django Slow Tests, and this adds a piece of output at the end to record which tests were the slowest, so you know where to start optimizing. But I'm not aware of any ability to combine them together without performing a lot of class surgery and replacing different attributes inside of the Discover Runner, doing multiple inheritance, perhaps on several of the different pieces, and then there's no guarantee that they'd work together. So what is the alternative? The alternative would be a system based upon hooks, like functions that fire at different points, somewhat similar to Django's signals. And indeed, this is how PyTest operates. It has 20 or more different hooks that will fire all relevant functions at each point in the testing process. And because of its hooks infrastructure and the ability to compose things, there is a flourishing ecosystem. Over 700 plugins are reported right now. I'm the author of a few of those, and it's quite fun to work with. So if you are looking to improve your test runner and don't want to do some of this work, then do look into PyTest. Nothing remains but for me to say thank you for listening to me. Here are my details: Adam Johnson, that's at Adam Chains on GitHub or Twitter. That's me at adamj.eu. That's also my site, and where you can find out about other blog posts. There'll be a blog post of this talk, and also my book on speeding up your Django tests. And this GitHub link, which I'll paste in the chat, is where I'm hosting the slides and the full example for emoji output that you can copy into your project. So thank you very much.